Hello, Forecaster here again, and we are back for episode 92 of the Railcraft server Let's Play. And this is another episode that is going to take place in my test world. Because I said in the previous episode, I believe, that I was going to work on the casting system and complete the upgrades off camera and then show the result. The problem with that is that I haven't been able to complete those updates yet, and I don't really have anything to do until that is done, because the current project kind of hinges on the casting system being able to make alloys, like I've talked about in previous episodes. And I don't want to rush this. So this episode, we're going to see what the plan is. I'm going to show code in this episode. We're going to have a look at the caster program. And what I've been doing, I've been experimenting with the alloy system. So the problem that is holding me up is extracting the fluid from the alloy mixer, which, as it turns out, doesn't want to allow these liquid pipes to extract anything from them or from it. So I've had to use the refractory hopper to output into this refractory tank, and then I'm kind of stuck, because if I just straightforward feed this like that, it ends up back in the alloy mixer, of course, because that is currently open. So because this is unpowered. And if I just have the loop constantly on like this, that is what is going to happen. And that doesn't work, because once the fluid is in here, I can only get it back out manually, because of course it won't let me pull fluid out of these, even with the refractory hopper. And that causes a bit of a problem. Now if I put this in there, we can see that it doesn't extract. And even if I, let's see, get all of that out so I don't lose any of it. Even if I get this, let's get rid of that, a few blocks away. Oh wait, that does work. I put the tank there before with 2 pipes. It didn't seem to be extracting. Maybe I turned it off too quickly, so I didn't see it updating. Okay, so that works. So I don't need the refractory hopper. That actually simplifies it a little bit. But I still have the problem that I can't have this on all the time. I need a control. So the alloying system is not going to be quite as straightforward as the pure metal casting system, because I need to control this output or input, however you want to look at it, similar to this one, although not quite as precisely. So basically what is going to have to happen is I need to pull the source fluids. Let's actually switch over to IntelliJ for a bit there. So I've started modifying the casting program. And first, let's have a look at materials. So I've created a format for defining an alloy. So we have bronze, which is an alloy, of course. We have a value present that tells us easily if it's an alloy or not, that we can check in the program. Then instead of having just an address, an input side, and an output side, it has input 1 and input 2. And these are two tables that contain the name of the source fluid, the first source fluid, which of course correspond to a key for a non-alloy, and then parts, which is well, how much fluid we need of this. The smallest amount we can use, which of course is, in the case of bronze, which is 3 parts copper and 1 part tin. You get 4 millibuckets of bronze, which is the minimum amount you can make in an alloy mixer. And then we have the we actually don't need this because I decided to do it a different way, which means we don't need to specify the address there at all. So that's pretty simple. We have a pretty simple definition there. Then in items, we have the mixer address and the side. So I moved it here, and it doesn't have a cost, and I've changed the rendering of the items here. I put in an if statement that says if the item has a cost value, and the cost value is greater than 0, then it's going to add it to the list that we can choose from. Otherwise, it's going to skip it. Since the mixer item doesn't have a cost, it's not going to show it as an option. It is meant to be used internally when making alloys, of course. When I did this, I could have just blacklisted the mixer specifically here and just said if the key equals mixer, then don't render the item. But I thought as a bit of future proofing that I would make it so that if I omit the cost, then I can easily add other things here, whatever they may be in the future, without having to make further changes to the program. Except for whatever special case will be needed to handle those, perhaps. But I don't need to change this anymore and add more special cases to this if statement. It just looks for the cost. So I think that's pretty handy. Now for the actual processing itself, and this is where I decided to start recording. Here we have the casting function, which we can call to and send in an item, a material, and an amount, and it will basically it controls it has all the code that make that casting operation happen. It also sets the last request. Now I've moved the valve controls out to its own function. So we have a function called valves, and they take an item name, and then they will close all the valves except the one for the item you specify. So here you just call that and you send in the item you get. Now initially I was going to have this casting function handle both alloys and non-alloys, and then just have it, if you send this in with alloy false, then it's going to execute this bit, which is basically the old contents of the function. But if you send in alloy true, it's going to skip this bit and jump into here. And here I was going to have it control the valves. And then it was going to have some special handling for the alloy making. So it would direct both fluids into the alloy mixer, and then they would be mixed together, and then they would be extracted, and then it would close off the alloy mixer and open the requested caster, and then the newly mixed alloy will be directed there, and then the items would be made that were requested. But just before I started recording, I realized what I should probably do is split this into some smaller chunks. And I haven't quite decided how to do that yet, but I think I basically should have a function I can call to get a specific material input into the system. So instead of, although maybe that's not a great idea either. Like I said, I don't want to rush this, because as a general rule when programming, if you rush something, you might make poor choices, and that might make it more difficult to work with the program or whatever software later. So I need to revise the I want to revise the fluid moving code a little bit. Up here I added a settings block, and I want to allow specifying some tank sizes. So for example, the output capacity, which I guess that should really be input capacity. Let's it's a bit fluffy, because what I'm basically referring to is this tank here, and as you can see, this small refractory tank contains 16 buckets of fluid. And I'm not entirely sure how big of an issue that is with this particular setup, because the program will, it tries to move one clump at a time. So if you, for example, have requested ingots, it will move 144 millibuckets at a time. And because there is a small delay in between each movement, I think in this case, these pipes extract fluid quickly enough for that to not really be an issue. I think it's 200 millibuckets per tick, or is it per second? I think it's per tick. But I don't think it's really an issue. But there could potentially be, let's say you're forced to use, actually that wouldn't work. Let's say you're limited to a slower extraction rate, and this tank has a relatively small capacity, and if this fills up, you could run into problems. I could also look at what happens if the transposer or the fluid controller component fails to move fluid. I don't remember if the transfer fluid method down here, what that returns. If it returns true or false, depending on if it managed to move all the fluid, or if it returns the amount of fluid that was transferred. Whoops, I accidentally right-click there. Depending on which one of those, I think it's more likely that it returns the amount of fluid that was transferred, which basically means that I have to I guess I'm going to look that up actually quickly. So if it returns the amount of fluid transferred, I'm going to have to do a bunch of math to keep track of how much was moved and how much remained, and then wait for a little bit, and then try to move the remainder, and then continue with the loop. Let's see. Tank controller is what it's called. Okay. No, that's not it. Does the transposer have different methods compared? I thought the tank controller had the same methods. I guess not. I guess I remembered wrong. So let's. What? Why doesn't? Why can't it? It's not finding the transposer. I am spelling that correctly, but it's not finding it. I guess I'll have to look in the list then. There is the transposer, transfer fluid returns a number, which means that it most likely returns how much fluid was transferred. So basically we would do something like that. And then do local remainder, no, remainder equals cost minus transferred, and while remainder greater than 0, then no, do and then we want to use the same details but do that, and then we're going to do an OS sleep for 1 second. So then if the transferred amount was the same as cost, remainder will be 0 right away, so then it should skip this loop. Otherwise, if transferred is not high enough to cancel out the cost, it's going to go into this loop because the remainder is greater than 0, and then it's going to try to transfer remainder again, and then it is going to see how much was transferred that time. And I should probably actually put this in the beginning there, so it waits first and then tries to transfer again. Then it's going to calculate the remainder. It's going to subtract the transferred amount from remainder until nothing remains, basically. So even if the tank drains very slowly, so you're trying to again cast an ingot, there is let's say, so 144 millibuckets is what you need, and that, let's say there's just 44 millibuckets of space in the tank for some reason, then it is going to transfer those 44 into the tank, and then the remainder is going to then transferred is going to be 44. And the cost is 144. So, or is it? Wait, is it 122? It's 122, isn't it? Shoot. What happened to NEI? God dang it. I managed to turn off NEI somehow. Thought the shortcut for that was O. Okay. Where's the ingot caster? No, it's 144. I was right. I had to make sure. Now where was I? Yeah, so cost is 144. Transferred would be 44. So remainder would be 100. So when it comes back to here, it will try to transfer 100. Let's say 20 millibuckets of space have opened up in the tank. Fluid drains out of it very slowly for whatever reason. maybe the caster is backed up. So it will transfer 20, and then from the remainder, which is 100, it will subtract 20, so the new remainder will be 80. And then it will come back to this loop again because remainder is greater than 0. It will wait for a bit, and then it's going to try to transfer 80, and then it's going to keep doing that until it's transferred all of it. And then when it's completed the entire operation, the entire move, then it's going to be able to increase made by 1 and continue with the main loop and try to transfer another 144. I have no idea if that explanation made any sense whatsoever. But yeah, I think I need to look over this code a bit, maybe split it up like I said. I also, maybe I just want as you can see, I was going to have this, like I said before, I was going to have this function handle both alloys and non-alloys. Now I'm probably more leaning towards leaving this as is and then creating an alloy function instead. So local function alloy, and then an item is chosen. Material is still chosen, and an amount is still chosen. We have all of the same choices. We don't need that anymore, and we don't need this, so we can undo this. And then instead, and it was still a good idea to move the valve controls to their own function, because then we can just do this. And then we want to, the very first thing is to shut off all of the casters and potential other items, and want to open the valve to the mixer, because that is where we want the fluids to go. Now, here's where I could use a regular input function that just grabs raw metals, pure metals, and pulls them in, because I can use that both here and here. So really what I could do is I could call this function if I had a way to make it not manipulate the valves. Maybe I should do this outside, because all this does basically is pull. I guess this just pulls raw metals, like the function I just said I wanted, I already have, because that's all this does. It just counts based on the amount and the cost of the item. It pulls in the right amount of raw metal to make that many items. Maybe I should just put in a cost instead. I have to redesign this a little bit, but maybe not as much as I thought. And then I could have a new cast function that just gets the cost and passes this and has the valve. So I would move the valve function out of there. Actually, what I would do is get this off, and then local function request raw metal. Get rid of that n because we have one already. And then we want cost material and amount, right? Did we have an amount? I think we had an amount. Yeah. Not sure what we were using that for though. Let's see. So cost, we no longer need this bit. That we should move to here. So here we're going to call request raw metal. And then we're going to take this cost, put that out here, and then pass that in here. And then F material, F amount. Although I'm still not sure what. Okay. We need that for that. We should rename that to operations in here. But basically this should work exactly as it did before now. But we have abstracted it a little bit. So now we could use the same metal request function in our alloy function and avoid redundant code. So we've run out of time, and I'm going to continue working on this and hopefully have made more progress by the next episode so that I can hopefully we can use this by then on the actual server. Otherwise I'll just have to make another progress report episode, I suppose. But hopefully we'll be able to actually use this to continue with the electric railway stuff we are working on. We'll have to see. So with that, I will see you then.